Today, I will present project. The project is called OPAT for Ocean Plastic Alert and Tracking System. We are not tracking fishermen. We are only tracking plastic on the ocean. So just one word about Geomatis. Geomatis is a French SME specialized in geospatial information system development. Really focused on standards and geospatial standards. We are a member of Open Geospatial Consortium, and we are promoting interoperability in our systems. So we are here since more than 17 years now, and we have developed a software universe dedicated to process every kind of geospatial information, satellite imagery, sensor observations, and so on. And more recently, about less than 10 years ago, we decided to work on big data analysis, and more specifically on the Earth observation domain. So in 4 years ago, we usually we are developing system for other company and big company and or institute. For example, we are working for French Space Agency, Japanese Space Agency, European Space Agency. We are working for naval industry and French Marine, and so on. And more recently, we decided to develop end-to-end products. One called EpiWise for epidemiology. Logo is water quality monitoring, and OPAT for tracking plastic on the ocean. As everybody knows, there are a lot of plastic in the oceans, and the problem is not resolved for many years. We are good in processing data to identify some information on it, and we decide to start using open data satellite imagery to see if we can find some marine litter or different kind of objects that are floating on the oceans. For that, we won funding from CNES and European Space Agency to prove the feasibility of the plastic detection on the ocean at different resolutions. So detecting plastic on the ocean is not an easy task, because there are big dump of waste that are floating. It's easy to detect because satellite can the satellite resolution of, for example, Sentinel-2 optical satellite can detect big piece of plastic on the ocean. But when you want to detect small packet of plastic, it's more difficult. So optical imagery is not enough to detect plastic. So, and we have to find other way to identify where the plastic is. So we decided to look at different oceanic phenomenon like sea currents and so on to forecast where there are plastic aggregation. So for that, we have to process a lot of data. We have to drill down a temporal series of satellite images. We have to do data fusion between moving feature and environmental data provided by satellites. So we have developed this solution which is a connector for data lakes, and which simplify data management for the data scientist community in order to develop new algorithms to do the detection. So one other problem is the temporal resolution of satellites, even commercial satellites. For example, with Sentinel-2, which has a temporal resolution of five days, you have to follow the drift of the plastic during those 5 days. And after 5 days, if there are clouds with optical satellites, you can't see where the plastic is. So we have to work on different kind of solution to track the plastic. Here we have developed we are forecasting the drift of plastic and verifying after a period if the plastic is still there or if the plastic is at the position we forecast it. So oh, sorry. Okay. So the feasibility is one thing, but one of the point we have to address one other point we have to address is economic credibility of the project. Detecting plastic, it's okay. We can do that, more especially for big climatic events where there are floods and hurricane and so on. There is a lot of big aggregates of plastics that are arriving near the shore. But if there is no economic model to pay for the detection, it's useless. So we have identified different stakeholders, and for example, the touristic towns that are near the coastline, they have to keep the beach clean, and it costs a lot of money. Cleaning the beach with cleaning the beach on the beach itself means you have to wash the plastic after to extract sand of the plastic in order to be able to recycle it. So it's a lot of work, and economically it's not really good. And catching the plastic directly on the ocean is a good point, because the plastic is clean when you get it. So we started to work with some city of the French Basque Country, because the French Basque Country 20 years ago was totally flooded by an ocean of plastic coming from huge waste dump in Spain, which was near the ocean, and they decide to pay fishermen during the touristic season to track marine litter and to catch it before it go on the beach. So they were really interested because the boat is navigating randomly, and by chance he can catch some plastic, but sometimes he catch nothing. And if we are able to give them tracking system, they can be more efficient in the way they are getting plastic, and they are consuming less fuel, so it's more green for the city. So another motivation was this big meteorological event. In the south of France, we have such kind of event. For example, in autumn, there are a lot of rain and a lot of flood. And at that time, a lot of plastic coming from the ground is coming to the sea and is aggregating in big packets. So if we are able to detect this packet of plastic, then the cleaning of the coast will be more efficient. So this is just something we have done quickly before coming here. We have processed Sentinel-2 images around Florida after Ian hurricane, and the zooming process is not really good, but we have easily detected some really big packet of plastic here. So now the goal is to we are able to detect big packets of plastic, but now we have to test for other kind of sensors, for example, SAR, which is really useful when there are clouds, of course. But the SAR resolution is not really good to detect small amount of marine litter, and perhaps what we are looking at is when plastic is drifting since a long time on the ocean. A lot of algae are developing on plastic, and the surface of the ocean at that place is modified, and then with SAR, when processing SAR, we are able to detect, but it's not really accurate, but we are able to detect some plastic. So what our goal is we want to develop this project in different way. Of course, for local authorities, like I explained, we want to talk with company who collect waste and who transform plastic in order to create a value chain that could be useful for the economic credibility of the project. And then we are starting to look at different kind of customers for this system. So that's it.
Thank you very much. We'll hold the question toward the end, so we move on to the second speaker.
Okay.
Is that okay?
Okay.
Yeah. So, are you the next?
I don't know. There's like 3, right?
Do we have Edward Swallows from here? So he's not here. So Maddie then. So Madeline Cowell is an engineer from Ball Aerospace, She's also a member of the International Committee of Marine Debris and specializing marine debris. Thank you.
Thank you. Yeah, so I am a representative of a larger task force and a steering committee that really kind of takes together different space agencies like the European Space Agency, NASA, and we have JAXA, and I believe the India Space Agency as well. And ultimately, we sit under the International Ocean Color Coordinating Group, which is a mouthful. And I'm going to say another mouthful, which is then we're the task force in the subgroup of really focused on remote sensing and marine litter and debris. So I guess I can do the next slide. So who are we? I think we don't necessarily have a solution, but really what I can offer is a network. And really what we're trying to do is connect a bunch of people of like-minded research to understand really what are the limitations and what are the gaps in which we can kind of use as a foundation to jump over hurdles. We really love coordinating. It's hard. Time zones are rough. I think we're a pretty strong force in Europe. We've got some US contingency, but you're also trying to loop in Hawaii. And so we do our best to get everybody included. But really, all of us seem to contribute in some way or form to the research. I think really we're a bunch of scientists and researchers who are looking to see what potential there are in the technologies and figuring out what kind of roadmap could we maybe develop to help kind of answer these questions of, where is the litter and what can we do about it? So just a little bit of history. I think this field is relatively new, and it always blows my mind with how quickly we've been researching and contributing to the world of science. And ultimately, it all started on remote sensing specifically. I shouldn't say all plastic research started in 2016, but when it came to remote sensing and understanding what could we do with sensors, it really started in 2016 at the University of Hawaii. Led by Nikolai Maximenko, who's a modeler and really is interested in understanding the transport of the debris. Oh, I didn't realize I was pushing buttons. Then since then, we have had multiple workshops. The European Space Agency, I think, took up the next torch and really kind of continued to cultivate the community. And then since then, we've really started to see funding opportunities in the space agencies themselves. ESA being one, NASA, which I can say thanks to because that's how my research is funded, and the Portugal Space Agency has also shown some projects through funding. So the task force contributions, just over the last year, we've been at a bunch of different events. I'm excited to be here representing just another way for us to try to get out in the community to say that we exist. Kind of the most notable that most recently happened was the UN Ocean Conference in Lisbon, Portugal, where we talked about an integrating marine observing debris system, and then also the 7th International Marine Debris Conference, which was in Korea. So ultimately how we've structured ourselves, we're in 4 different core topics. We have our technologies, then we have our algorithms. You can't do anything about algorithms unless you have data, and then ultimately we have our interdisciplinary aspects. I lead the core topic 4, so trying to engage, get people to know about us, and talk about, I swear I didn't touch it. Oh, is it on? It's probably, I'm going to keep having to touch things then. So in terms of, we have our CT1 leader, which is Victor out of Plymouth Marine Laboratory. He is leading a group to really understand what is current and what is emerging in terms of technology itself and understanding the gaps and opportunities. Algorithms, it's really understanding, our state of the art. That's led by Manuel, is in our core topic 2. Really, it's like, okay, once you have this data and you've collected all these photons, what do you do with those photons? How do we actually say what's of importance? And then data sets, I think that's one of the biggest challenges is that remote sensing has tons of data and tons of history, but when it comes to validated data, the data that you need to actually say something about what's been collected is very scarce. And so we're always trying to understand what are the needs in this section and how can we help generate or push for more data and really make it open access. So in terms of our technologies of interest, we've heard a lot today about the optical remote sensing, so multispectral and hyperspectral. Really what we're interested in is in the near to the SWIR, shortwave infrared. There's some really great polymer features from thinking about like how you could distinguish from something like phytoplankton. We're excited, actually, I should say, I'm really excited about the laser base. So thinking about ocean LiDAR and understanding what could the backscatter return, what could fluorescence return look like, and kind of how could we maybe ID and do a signature off of that end. There's also, I should say the depth is very deep on each of these topics. And then we also have our microwave based. And that one's really, again, SAR we've talked a lot about today as well, but really that surface roughness. Kind of some of the thoughts there is if you have a really large presence of plastics and you have wind events happening, it's actually that deviation of an expected dampening that might lead you to, beyond just surfactants, maybe microplastics, macroplastics could be contributing to the signal. And then all of that has to be in concert with the retrieval algorithms and making sure that we understand the state of the science. Really any platform, as long as we're not maybe in the water or doing point samples, is what we're interested in. So whether it's shipborne, drones, ultimately getting up to satellites is kind of the, I wouldn't say the holy grail, but a really exciting piece of the puzzle, because it really does give you that global coverage so that you can start to do a true global budget instead of just localized regional studies. Oh, I went backwards. So ultimately, the kind of applications we're trying to target is we want to be able to detect, just say, is it there, is it not? We really would love to identify what kind of plastics, I mean, beyond just what sits at the surface due to densities versus what sinks. I think we could maybe infer what type of polymers are at the top. But ultimately, it would be nice to be able to bring it so that we knew what the sources were. It would be amazing then to get to quantifying. I think one of the big things is we keep hearing studies coming out about these are the estimates that we're dumping into the ocean. But right now, trying to close that budget is really challenging because we do have limited resources to go out and do point sampling. So getting to that quantify would be really huge. And then ultimately, now you've got all of this, you want to start tracking it. And especially with the light of like the UN Ocean Decade, the newest plastic treaty that's been proposed, all of those different pieces are going to be informing policies, and we want to be able to understand how are we performing to those policies. But the biggest challenge is size and variety. I should say size, though, right now with our current set of satellites and thinking about spatial resolution, you really need large aggregate data, as we saw earlier. It's one of the biggest challenges. We do have a scale limitation because we need enough accumulation for us to get a good signal off of it. Beyond that variety, I said that there are some great features out in the shortwave infrared. Shortwave infrared is notorious for being absorbed by water, so not a really great mix. And so it is still a challenge to understand, what kind of variety of debris are we really working with when we see these large accumulations. So ultimately, where we are today, I think a lot of people will agree aggregated plastic seems to be, where our eyes focus. But I think kind of going back to the purpose of this group, a lot of us are researching kind of what's coming up in the emerging technologies to come. So just to kind of do a really quick highlight of some of the activities from the different space agencies, ESA is just about to complete their campaign, the Discovery campaign, which is really like the first time, at least in my memory, of being excited about all the funding getting into the marine debris and remote sensing research. So really excited to see how everything will conclude. These are just some snapshots of the types of work that's being done. Anything from tanks in the lab, 2 planes, 2 large deployments. I swear I'm not touching it. And then also getting to the point where we're starting to model and understand the impact. And in terms of NASA activities, we've got the ROSES grant, which is kind of our major funding line. And so we had 3 different projects out of the Ocean Biology and Biogeochemistry program. Nikolai Maximenko out in Hawaii, he's got a couple projects that are really leveraging citizen science out in Hawaii. And then I also have a project that's looking at fluorescent signatures off of plastics. And then in the Portugal Space Agency, I think really, again, it's complementary, thinking about how do we actually take a lot of the EO and optical sensors and take them out to the field, and then a lot of AI and algorithm development. Because again, it's great to have photons, but if you don't know what those photons are saying, it's really hard to disseminate the information. So ultimately, why I'm here is to tell you we exist. Our task force is trying to be a one-stop shop where we try to keep everything up to date. We've got a nice, upcoming events, research topics. And this is the slide I wanted to actually have the most static, because this is a QR code to scan to get to our website. Overall, we've been keeping like a bibliography that anybody can come in and use, as this is like the top hits for marine debris. We've got 81 peer-reviewed papers as of last month on our website. We've got 13 data sets that are available, so if people are interested in that. I'd like to do a quick plug, though, for Ocean Scan. That's an ESA-funded activity, and they're actually really trying to do that ground validation and provide an open data set for people to do machine learning and different types of algorithm training. And then ultimately, we have tons of repositories linked. So we're really trying to be this place where you can come and start to do the learning journey. Or if you're seasoned and expert and feel like you're missing, please let us know. We want to continue to grow the community. So we want to make sure your research is captured. So way forward. Ultimately, we're really trying to understand what the limitations are of the current technology and understanding what gaps we should pursue when it comes to emerging technologies. I think one of the big things is really trying to fuse all the different data sets being collected, anything from people sampling on the ground, trawling nets, cleanups. I mean, there's lots of opportunity for us to start collecting data, but there's no harmonization, and we're really trying to be in step with other organizations like IMDOS, which is the Integrated Marine Observing Debris System. And then ultimately, wasn't done yet, but we're really trying to get an idea of like, where are we going? And the biggest feedback is getting the stakeholders. I think it is very similar to the IUU talk in the sense, it's great we can detect it, we can find it, but now what? And I think that's really the missing link in terms of turning on funding and saying, this is why you should fund these projects. So if you know anybody who is really passionate about this and has maybe pockets, it would be great to have the conversation to understand what data you really need in your hands so that we can continue to inform the research. And so with that, I think I'm going the wrong way. Thank you.
Thank you very much. So I have yeah, you can sit down. We have 2 microphones, I guess. So, we can have Q&A. I first want to tell you the bad news. So the first speaker I'm looking for, I just checked my notes. The program changing dynamically, and then from Germany, he was not able to come because of emergency reasons. So that's a bad news. If we are missing one talk in this panel, but the good news is we have more time to ask the 2 speakers here, and also to discuss any topic you may be interested. So who want to ask the first question?
Can I actually make a quick note? I forgot to say core topic 3 leader Shambu Garaba. I was just going through my head and saying, I think I missed someone, so just wanted to make sure his name was out there as he's on the task force.
Yeah, I think Nikolai from Hawaii moved your slides. So
yes.
Yeah, I'm pretty sure. He's a good friend of mine.
Oh, good.
Any questions? Go ahead.
So for the French example where the fishermen were going out and collecting the plastic, I was just curious, how do they make sure people don't game the system and say, oh, I collected this plastic, but they just got it from from their own recycle bin? For the fishermen that were being paid to collect plastic from the ocean, how do they make sure people aren't taking advantage of the system and just taking plastic from from the neighbor and saying we collected?
Yes, for the Basque Country, it's a bit the fisherman was for the Basque Country the fisherman was about to retire, and they employ it to do the job, but he doesn't have nothing to gain when keeping or not some plastic. But what's really interesting with this project is that the fisherman do it for about 10 years, and after his son now is doing the same thing after him, and we have 20 years of data about what they have collected. So that's the interesting part of the project, is that we now we are able to verify on the field, to have field verification of what we can look on satellite images. And what is more difficult is at the beginning, the fisherman was not pointing the place where the plastic was. So we have to try to look at the pattern of the trajectory of the boat to identify where he was picking some plastic. But after that, after processing the data set, we now have a database of where some plastic was, and we can get some satellite images, old historical satellite images, to train our algorithm to detect even Landsat images, spot images, and so on, historical spot images, which are free right now. And so this is an interesting part of the project. But of course, if paying fishermen to grab some plastic on the ocean is something that town want to do, because it's less expensive to pay a fisherman than to buy a boat and pay people for the season to do the job. And of course, after that, we have to verify if the plastic is real marine litter or not. But that's another problem.
It's a great question. I don't think I know the answer, but I run into another company in the Bay Area a couple of years ago. It's not tracking plastic, tracking kind of fish, and then the good part, basically by analyzing the materials in the air, and they can track where they can fingerprint where they come from particular continent, from the countries. It's like a device, basically like a fingerprinting, by saying I'm exposed this area in Indonesia, in Bali or something, and then moving through Japan. And so they will be able to fingerprint just by tracking through the air exposure. I think they talk about tuna or fish or something. So seafood from the ship to the table, they can plot the trajectory. This is like a few years ago. I don't know whether that's become a unicorn or bankrupt, or I don't know. I even don't remember the name. But there are companies developing that kind of tracking technology. I think for ocean, the environmental analysis probably eventually will catch up to analyze, here's the water, here's different type of water, and here's on the boat, and then track them, right? So I think earlier panel, technology innovation probably will help to address that question. So any other question?
So I tried to do some satellite work on plastics a long time ago in my PhD. I think it was like 2014. And one of the problems we had is that the best satellite data is really on land and near shore, and like out in the open ocean, the satellite paths just kind of skipped it. And we really care about the middle of the Pacific Ocean, and most satellites just really skipped that. So do you have big empty spaces in your data sets, or have you been able to kind of find that data?
No, you are hitting the problem that we have when it comes to trying to understand the open ocean problem. I think floating plastics is really our best bet. So that actually also limits the number of polymers that you can see. And you're absolutely right. The Landsats, the Sentinel-2, those are definitely made for land imaging. And so when we try to repurpose it, that's awesome. But the signal, the ocean's really dark. And also that dynamic range to go from dark ocean to the land is also another challenge. So in terms of we are scarce on data. When I say that, it is, we're looking for things off of coastlines and trying to understand, okay, now that we know these things off of coastlines, There is actually, since 2014, and I'm sorry that you missed this window, but ESA did actually open up Sentinel-2 to collect over the southern part of the North Pacific garbage patch, if I remember correctly. And so they just opened it up for a brief period of time because as it is, I know Landsat probably better than I do Sentinel-2 just based on where I sit, but I do know there's a lot of concern and risk that when you start to turn the satellite on in places it wasn't planning on operating, you have to convince a lot of people that that's a good idea. So in terms of I know we're trying to leverage opportunities like that and get really deep into the data, but it's a really challenging problem because beyond just even the sparseness of the data, with our sentinels and worldviews, we really love those near infrared and those SWIR bands, and sometimes we'll use information from the red, green, blue. Those are all at different spatial resolutions. So you're now also trying to understand, okay, well, if I've got 10 meter resolution in my VIS and I've got 20 nanometer resolution in my SWIR, what am I really saying about, what's in between? So yeah, it's not easy. And I think that's why I think we get so excited about the emerging technologies. I feel like we're really trying to push the current constellation to its edge. And we're trying to squeeze every ounce out of it. But when you're talking about open ocean versus coastal zones versus terrestrial accumulation zones, I think they currently all look different. And so I know there's a lot of people who are interested in, well, what does like a unified plastic sat look like? And so I think I'm really excited to see where this future kind of goes. But I do really think we need to nail down the application. Just because we can build it doesn't mean we should. So I think that's been like the biggest barrier, is making sure that we're all on board with the same desires. That was a long-winded answer.
That was great. That was great. Okay, I'll ask another question. I don't see any hands. Speaking of pushing it to the edge, what is like the smallest size range of plastic that you guys can analyze?
So I'm actually maybe going to phone a friend with Mitch. If worldview spatial resolution, is that a meter? 3?
No, they're down to a meter.
They are down to a meter too?
Yeah,
25 centimeter on like the panchromatic sharpened, right? Yes.
Yeah, but they don't gather data everywhere, right?
No, you have to task it. Yeah. So that would be the answer, is like that pixel is really going to determine what you can see from spatial, and relying on one pixel to give you enough information probably isn't enough, and you need multiple. So you start really building up. And I'd say with a lot of the free satellites, we're talking, it'd be great to see something 50 meters or more in a MAT. But in terms of like thinking about the worldview, I know people have pushed it. I don't know the limit, but I do know that normally that spatial pixel resolution is the factor.
Okay.
Yeah.
Kind of tied to that, and you hinted at just the conglomeration of plastics, how it can kind of change the nature of the sea surface. So does that, one thing I hear on the news all the time is the discussion of microplastics and the small things. Like, do those have any signature? Is there a path forward for tracking those?
Path forward, I won't necessarily speak to, but I can speak to how people have published work to maybe draw some conclusions of how you can use Cygnus data to do microplastic concentrations. And so that was a study out of the University of Michigan where I would say a lot of things still need to be understood. Like I mentioned, the surfactant factor of dampening your surface is definitely a big driver, and being able to decouple that from microplastics sounds like a pretty tough challenge, but I know that they're actively researching that. But really, when I've seen microplastics, it normally has to be into some comparison to a model that then takes another wind driving model to say it's the delta and the anomalies of interest that maybe gives me some hope that I'm seeing something of microplastics. So much more of a derivative measurement than a direct measurement, but that's at least my experience from satellites.
Yes, another point is hyperspectral imagery, which is really, really useful to detect what optical imagery or radar imagery is not able to detect. But there is not a lot of sensors in space right now.
Coming though, right?
But it's.
I heard that 10 years.
Yeah.
But it's something I think really useful to enhance the model.
So just adding to Peter's comment, you're correct to point out a lot of the work currently is focused on patch plastic, large scale plastic detection, and etc. But really from previous work like Jenny's dissertation work and other folks, really the microplastic, almost to the dissolved micron level plastic is what's really impacting ecosystem and biogeochemistry. And we keep talking about spatial resolution and the detection limitation of satellite imagery. What about treating these microplastics like some of the other existing Earth observables, like treating it as SPM or treating it as particular organic carbon? So those things you can't detect by spatial resolution, but they have optical signatures collectively when they're concentrated. So has there been steps, or is IOCCG thinking about detecting microplastics from that approach?
I think we're always interested. Microplastics is something that I get really excited about, more because I think I've seen some really cool strides on going beyond just mantitrals and thinking about, that's how we do our accumulation for microplastic studies, because there's so much citizen science out there that people want to contribute. And so if we can give them ways to do microplastic sampling, we should be equipped to do so. So there's a lot of technology coming out of that. When it comes to satellites, I think one of the things that, sticks with me, and I might be misquoting, so please don't hold me against this, but the concentration itself, it's hard to know how it varies and what exactly is happening in order to probably process a signal. I think the microplastics question, it's so multifaceted and so tied to physical ocean dynamics that, and I have this fear of, it's been there for how long? So really, how do you pull a signal out of something that probably already is just kind of a basis, so almost like a bias? And I think we aren't quite ready to say anything on sensors, but I do think that there's a lot of work to be done about maybe trying to figure out how do we leverage other data sets that maybe studied phytoplankton or things that also are of scale, but maybe we weren't looking at the time, like in the 60s and the 70s. So trying to understand how can we start jigsawing that puzzle together, I think will then give us the opportunity to think about the future. Because I always think, what could LIDAR do? We talk about phytoplankton blooms and things along those lines, but again, because microplastics and the concentration is sometimes, as I'm told, it's too little to do much, that I just don't know what we're going to find. So stay tuned.
Hi, thanks. This is such an important topic. Thanks a lot for your talks. I'm wondering how much effort is being put into detecting the sources of the plastic pollution. And as difficult as it might be, would it be effective to create a database of every recycling center, every dump site, every everywhere that plastic goes, every ship that transports it back and forth, and find those places where they're, because isn't that how it's really happening? It's from a concentrated source in a lot of ways, and then coming into the ocean and identifying those places and stopping the plastic there before it gets all the way out in the ocean for years and years and breaks down and becomes microplastic.
I can speak a little bit, but do you?
No, please.
Yeah, okay. I can talk for days on this topic. I love thinking about our source and where things are coming from. So when I first entered this research, it was all about actually finding derelict fishing gear. Nylon was a really interesting polymer. Fun fact, it sinks. So that was a bummer. But in terms of understanding its use case, it was clear derelict fishing gears, that's a source. I can go to the fishing. Thinking about tying into everybody else's conversation today with AIS and maritime awareness, it's amazing what we know there. But when it comes to actually starting to shift the lens and looking upstream, I think there's a lot of anecdote and stories, but I haven't seen a really good resource. And maybe it's just, I don't know how to find it, that says, this percentage to, we know what we consume. So that's always everybody's starting point. The US consumes so much. I know we're in the top 3, I feel like, and then other countries contribute. Okay, so we know that the US is the source, but we've heard anecdotally, we've shipped recycling out to China. China closed their doors and said, no, we're not accepting this anymore. And we tried to find other pathways to get the recycled goods elsewhere. And then it, got to the point where I've heard amazing, wild stories of people basically taking it to other countries who aren't necessarily equipped to handle all of our trash. They just go upstream, dump it, and then they kind of let it do the rest. And so I think some of the really cool efforts I've seen on trying to get this, it's almost an intelligence view on what is the supply chain of plastics on the back end. And it's the Minderoo Foundation out of Australia. They have a global plastic watch, and they actually use satellite imagery to find illegal dumping zones in Southeast Asia. Actually, and I think they've expanded it. I almost want to say I've seen something in South America, but it's been a bit since I've checked their website. And so they did the first attempt of showing like illegal dump sites. But then, there's lots of questions of, okay, let's just take the US as a use case. Recycling practices and methods vary state by state, city by city. It's like there's no real good standard way to tackle the problem just yet. And that's where I think I'm really lobbying for the policy side of it, the regulation. I know in the fishing talk prior to this, without regulation of saying this is how we should handle our waste, it's up for debate where it goes. And so it's such a large scope that I haven't seen good path forward. But it doesn't mean that it doesn't exist. And actually, maybe by me being here, we can get the maritime folks thinking, with things like AIS data and tracking shipping containers. And if my presence at least just gets that conversation going of thinking about the supply chain of things, I think that could be really powerful as a way to even talk about where do we need to look for remote sensing, tasking, going back to that instead of just relying on 16 or 8-day revisits. So anyways. Long-winded.
Can I just follow up on that?
Yeah.
Couldn't you get a good handle on that with just 10 or maybe 100,000 sensors that you sneak into plastic all around the world and just throw it away? And
so there's some really cool, so Scripps actually did like a plastics challenge to the Rady Business School of saying like, oh, how do we, even tackle this problem? And one group of students actually said, well, I'm going to put a bunch of sensors in my trash and figure out where everything goes. So like I've seen that kind of deployment before. I've also heard rumors, and the only reason I even got, fluorescence is a very interesting property of polymers, but Europe has even talked about, dyeing the polymers with a fluorescence dye so that it's easier for us to find or track or sort and things along those lines. So I know that there's conversations happening, but I haven't seen like a tops down, thou shall do this yet. And so I think the biggest hurdle to make that happen is the cost.
Yeah, but I think that's not that expensive. Like, that's within the realm of big grants or, the Gates Foundation or something like that. Someone could do this in a year or two.
Yeah, so I have on 2 paths. On the grant side of things, when it comes to finding things you can apply to grants, especially marine debris, plastic pollution, there aren't large buckets of money. I have searched and I have tried to find government funding. So that's been tough. But then on the nonprofit side, nonprofits aren't necessarily interested yet. I think right now, methane, greenhouse gases, all of that emissions story is really dominating kind of where we're throwing our money. And I think plastic pollution is kind of just, it's wild how interconnected the two are in the thinking of like when we create these polymers, the emissions we dump into the atmosphere. Like it's a similar story to oil and gas, but it is very much behind in terms of funding. And actually, I do have one resource that maybe I can share to the Whova app that kind of does this tie of the cost of plastics, the cost of like how much are we actually funding it, and how far behind are we in the science? Yeah. Okay. Cool.
Can I follow up on that question? So the second C in the IOCCG is coordination, right? It's coordinating all the ocean color community. So, so what has been some of the efforts from that group to coordinate with institute data? Because I think one of the big effort that should be, people should invest in is to do the matchup. I think there's enough satellite data. There needs to be more coordination efforts, more matchup between the satellite data and the institute data. So that way, when we write algorithms, we can build better machine learning algorithms to detect, especially the microplastic component.
Yeah.
So what has been some of the efforts from that group? Because I'm not directly involved, I only read their reports, and
I feel like you are at the same seat that I'm at, in the sense that, so the IOCCG, the task force itself started in early 2021. I am new to the group, and it has been trying to go to conferences, to talks, and say, we're doing this. I think that's probably the biggest output we have right now, is that we've held a couple webinars where people can join in, but ultimately it's trying to find platforms to have these conversations and make sure people are actually talking. I think that's been the biggest hurdle, but I think at least what I find the most rewarding, and when I say, have I done something for IOCCG's task force, is, I've been trying to make those connections. I hear about, there's I hope he doesn't mind that I use him as this example, but Beckett out at Woods Hole Oceanographic Institute has a microplastic sensor that I think is really interesting based off of flow cytometry. I came across it at a conference at a poster, and all I can do is keep forwarding that paper. And I think really, in terms of like when it comes to coordinating, especially internationally, especially when you're competing with policies and just like how people actually attack this problem, all we can do is just kind of accumulate the masses. And so I know my selfish plug, so I'm on the interdisciplinary side, and I want to see more workshops where we are trying to tie those user communities. I'm going to be applying for workshops and trying to get money so that we can actually have these conversations, try to write white papers to help inform the community. And so, yeah, but at the same time, because it's an international group, it's slow. It's not a team I can just walk down the hallway and say, we're doing this week. It's very much trying to make sure that we have the momentum going. And so, unfortunately, we can point to lots of things. I think OceanScan, in terms of validation data, is a fantastic platform where people have been uploading their research data points of like, hey, I threw out a target that was 10 meters by 10 meters in the Mediterranean. Here is the lat long, the day, and I used Prisma and Sentinel-2. And so that stuff is currently existing, but it's not owned by the IOCCG. It's kind of, we definitely are trying to make sure everybody's matching to it. And that's all we can do. But that's kind of probably the most coordinating output.
Let me follow up on that question. And a lot of this seem emerged, the integration between satellite and in situ data. Satellite can see better and better, but it's always limited. So Mitch's presentation clearly showed the fusion many other speakers talk about. So if I have a hypothesis, let's say hypothetically, if we can send 1,000 boats Julie produced, just imagine, assuming she can produce 1,000 boats tomorrow, next year, and then we're keeping her busy, her team. What type of sensor and data, I want to ask two speakers, you would like to, money is not a limitation. What sensor and data you want to collect? One. Top.
One?
Mm-hmm. 1, 2, 3.
Okay. You can go first.
What data you meet your unmet need, solve your biggest problem? What's the top sensor? It's 2.
As a top sensor?
Yeah, sensor and data.
It's you. If everybody can get my mobile phone application, and can everybody on a boat see plastic and look, put a localization of the plastic and take a photo and take information about the plastic, we could have an incredible database to.
Okay, so you talk about people with
we are working. Geospatially speaking, we are working on sensors and moving feature and so on, and we are working on system sensor systems, sensor platform, and so on. And for me, the best sensor is a human, because you have eyes, you have ears, you have everything you can test if you can.
But for open ocean, what about a robotic? For example, in the open ocean, if we have a robotic platform in the middle of the ocean, people usually cannot go. What sensor come to your mind? Yeah.
I'm very sorry.
only have 2 minutes.
Yeah, just to
Oh, no.
clarify, I think a better way to think about this, and I actually have an incentive to ask this question for another project. In addition to sensor, what do you want to measure? Do you want to count plastics? Do you want to count the quantity, volume? What's the observable that you're interested in?
Yeah, if you cannot come up with sensors, name a data set. That's fine too.
Oh, go, yeah, go.
Sorry.
What's
put in the
interesting,
spot.
it's a radiometric, the radiometric response of the plastic, but it's not the same when the plastic is young on the ocean and when it's old and so on. So that's why if you detect some plastic and you take a photo and you just enhance some information, metadata, and you put it on the global system, it could be helpful to train, for example, a deep learning algorithm to automatically identify what could be plastic on an image that you, or for example, to identify when sense an image from combined with another image and so on could give some a combination of response that could match with presence of plastic.
Sorry to cut you. It's optical imager, so go ahead.
Yeah. So my head spins when I get that. I'm going to pretend like I have the perfect sensor, and that sensor is going to be able to tell me concentration.
Concentration.
And so what I would love to see is something that sits at river mouths. And then what I would love to see out in the open ocean profiling, like I keep thinking, how can we leverage the Argo data set? I would love to see what's going on in the water column. I think lots of interesting hypotheses around like, oh, it's settling at the mixed layer depth, or it's getting all the way down to the surf, or down to the bottom. I think it's so unknown and so hard to capture that. If you had a bunch of autonomous vehicles out there doing one mission, I think that would be what I'd love to see, is understanding the transport of these things. Because maybe we don't need a satellite. Maybe we just need something that's looking at a river. Exactly. Yeah.
So Julie, take notes. You need to dive your boat.
Yeah. Yes. Well, I hate to be the person to make a comment and not a question, but I would say 90% of the plastic is smaller than what your cell phone camera can take a picture of. So I think it's important. I think satellite images, the big stuff, is really important. I think camera images and images off ROVs are really important, but I think it's also really important for us to make sure we are doing sensors of the really small particulate matter stuff, because that is actually numerically the vast majority of the plastic in the ocean is really, really small. And I'm not sure the perfect sensor exists yet. And I think a lot of people are developing it, but I don't really think it's out there yet autonomously. And that's why it takes so long for us to analyze our samples, because we have to do it by hand.
Yeah, really. Sorry, I had to cut it off. It's really exciting. I want to keep talking. You know, this is a really great topic and good interaction. We have a coffee break right now. The panel right after the coffee break is empty. So there's a speaker we're not able to attend. So we have an open slot. I ask people to submit questions. Another way we can have an interactive discussion on any topic. Maybe the audience can introduce themselves in a couple of sentences, what they're doing, and know each other better. The problem with this conference, you meet a lot of people, you have a hard time to know what they're doing. So give everybody an opportunity. We do have 45 minutes available in between before the final panel. We'll talk about sea level rise. So we're take a coffee break, think about the questions, and then come back 3:15, 3:20. We're going to have open discussion, introduction, debate, hypothesis testing, whatever you want to do. Thank you.